thought the only one the chut Maybe out of Bokka. Viên viên ngọt nhưng đã cháo lắm hả?
So we are going to start to the event with the Nobel Laureate Professor David Jonathan Rose, and for the topic, the future of science and human development. So to the table time. So very first of all, ladies and gentlemen, please be outstanding for the national anthem, please. Thank you so much. Please have a seat. Next, I would like to invite His Excellency Lai Chi-il, Director of the Royal University of Phnom Penh, to have the welcome speech. His Excellency, please.
For Physics 2004, ladies and gentlemen, it is a great pleasure to welcome you all today to this dialogue with Professor David Cross, who received the Nobel Prize for Physics in 2004 for his research on the strong force that holds subatomic particles together. His work led to the creation of a completely new theory in physics called quantum chromodynamics. It is a great honor to welcome Professor Cross to Cambodia, and we look forward to his presentation on the future of ASEAN and human development. In a moment, we will hear from Mr. Uwe Morawetz, the founding chairman of the International Peace Foundation, who will give us an overview of the rich series of dialogue with Nobel Laureate. This aim of this program is to promote a culture of peace, and this is something that the Cambodian government strongly supports. So we look forward to his presentation also. Following Mr. Uwe Morawetz, we will hear some opening remarks from His Excellency Secretary of State of Ministry of Education, Youth and Sport. Then we will hear from our distinguished guest, Professor David Cross. So, to which I would like to invite Mr. Uwe Morawetz to give us an overview of this series of dialogue. Thank you.
Welcome to the third ASEAN event series, Bridges, Dialogues Towards a Culture of Peace. Bridges is facilitated by the International Peace Foundation, a non-political, non-religious foundation under the patronage of 21 Nobel Peace Prize laureates based in Vienna. The events are hosted in cooperation with various local partners, including the country's major universities. Having started in November last year, Bridges is now being continuously held in Cambodia until April 2010, involving the participation of Nobel Laureates from all fields. The third ASEAN series of Bridges is an independent contribution to the Decade for a Culture of Peace and Non-Violence, which was initiated and promoted by the United Nations General Assembly. It follows a series of 350 Bridges events, which the International Peace Foundation has already hosted in Thailand, in the Philippines and Malaysia since 2003. Increasing ethnic, political, religious and social conflicts, and the helplessness to respond to them without further stimulating the spiral of violence, show us peace is not living good. It has to be constantly learned, experienced, and created anew. Peace is not a passive state. Peace is a process which needs time, attention, and the participation of all of us. And peace begins with education. The seeds of peace need to be planted in schools, in universities, in the young generation, in youth. This is why the International Peace Foundation cooperates with major schools and universities, as well as with UNESCO in realizing this Bridges program. We believe in the importance of the education and scientific community here in Cambodia by bringing the knowledge and wisdom of Nobel Laureates for peace, physics, chemistry, medicine, and economics to this country. What these highly in-demand Nobel Laureates normally see of the country are airports and hotels. They deliver the lecture, stay for one night, and leave. We have invited them here not only to speak, but to share, to engage, to listen. They come here not for one day or one event only, but for various dialogues and events without requesting any honorarium because of their real interest in building bridges, because of their real interest in Cambodia. It is our hope that these are not the first and final visits of these Nobel Laureates, but visits with many fruitful returns to build long-lasting friendship and to start, for instance, research programs or other forms of cooperation with local universities and schools. This is how Bridges could develop into a long-term and sustainable success for Cambodia to strengthen education as the basis for peace. I thank the Royal University of Phnom Penh and the organizing committee of today's event for taking up this opportunity of our cooperation and for inviting today the 2004 Nobel Laureate for Physics, Professor David Gross, to this prestigious university. We look forward to his keynote speech.
Peace Foundation, Excellency, distinguished guests, ladies and gentlemen, dear colleagues and students. I would like to begin by extending a very warm welcome to our distinguished guests from the Institute of Theoretical Physics. I would also express our deepest honor and gratitude for spending and sharing your valuable time with our colleagues and students and for your contribution to the dialogue for peace. We express our deepest recognition to your scientific work and contributions that are now to having knit closer to the dream of having a unified theory of physics comprising reality as well as theory of everything to better understanding how the universe works. This is obviously a great advancement for all the humanity. I would like to extend my warm welcome to Mr. Uwe Morawetz, founding chairman of the International Peace Foundation for the Bridges Initiative. We are deeply proud to host this series of conferences and the continuing dialogue toward the culture of peace organized by the International Peace Foundation. As you know, our recent history has been difficult, and many of our skilled people have been killed in the 70 years. Today, we look forward to a culture peaceful future. It is unanimously recognized that quality education plays a central role in building a better future. For more than 20 years now, the Ministry of Education, Youth and Sport has been working hard and has achieved an important progress in building schools in all the provinces, training teachers, and improving the curriculum. In the higher education sector, now we have more than 80 institutions covering most of the domain. There is the Royal University of Phnom Penh, the Royal University of Law and Economics, University of Health Science, the Royal University of Agriculture, the Institute of Technology of Cambodia, and the National Institute of Education. During the last 15 years, many young Cambodian students have been studying abroad to get the knowledge necessary to reconstruct the edge of our society. They are now back to the country, and they are contributing strongly to the building the capacity to produce the quality human resources who are the indispensable driving force for the development of the country and building a future remains still and need all our effort. The way is long, but we are committed and remain optimistic despite the major problems we are facing. In the context of globalization and regionalism, we know that the excellence of the program of our university will only be achieved through strong international academic collaboration and permanent exchange and dialogues. The presence today of Professor David Gross is very valuable, and I would like to say that for myself also I am very interested as one scientist, very interested about the future of science and human development. We really need for our society actually. So thank you very much for your attention.
So, I'm sorry, but before we start, I would like to take a few minutes in order to introduce Professor to all of you. So please, Professor David Jonathan Gross is a 2004 Nobel Laureate for Physics, the director and holder of the Frederick Gross received his undergraduate degree from Harvard University in Jerusalem in 1962, and then returned to the United States to continue his education at the University of California, Berkeley, where he received his PhD in physics in 1966. He left in 1972. During that same period, between 1970 and 1975, he also became a fellow at the Sloan Foundation. David Gross remained at Princeton until 1996, where he was named Eugene Huygens Professor of Physics 1986 to 1995, and Thomas Jones Professor also the Asian Fellowship, the Direct Medal, the Oscar Medal, and the Harry Prize of the Technion. He has received various honorary degrees and was selected to receive France's highest scientific honor.
Thank you for that introduction and for your hospitality here and throughout Cambodia. My wife and I enjoyed our brief visit to Phnom Penh very much. It's really, as you will see. I'll say a bit about what science is in general and how it contributes to human development in ways other than just providing us with new technology. But then I'll discuss what we don't know, after a brief survey of what we do know. I would like to say a word about one of the greatest gifts of science to humanity, which isn't just the tools that it provides, and rests, the development of the laser rests on understanding of quantum mechanics 80 years ago. It's a wonderful invention. But the most important gift of science, I think, is the scientific method itself. A new way of thinking that was really invented only about 400 years ago, and has been the reason science is so successful. But the gift of the scientific method goes beyond just learning about nature. It also can be used in ordinary society. The world is the requirement of science. So sometimes despotic leaders are for democracy. In science, everyone is equal. I can tell you about my theory of the strong force, the strong nuclear force, but anyone can get up, any of you students can get up and say, Professor, you are wrong. Most humane societies. Now, of course, the main goal of science is to provide knowledge, and it is quite remarkable how much we have learned in the last 50 years. I mean, we have discovered and understood the basic building blocks of matter. Atoms. Everything we see around us is just different collections of atoms held together by electromagnetic forces, by chemical bonds. And we've understood the structure of matter from the atom down to the nucleus. Quarks are the constituents of the nuclei, of the proton, the neutron, and the nuclear matter, and electrons which revolve around the nuclei to make up atoms. And we've understood the forces that act on the quarks and the electrons, the electromagnetic force, physical reality, and the forces which act within the nucleus that hold the quarks together. There are two forces that act within the nucleus. One, the weak nuclear force, that changes one kind of quark into another, is responsible for radioactivity, and the strong nuclear force that holds the quarks together. The history of the universe as it expanded from a very hot state, hot and dense little region of incredibly hot gas particles, and expanded rapidly, and it's still expanding today. We understand physical systems, chemistry, atomic physics, and materials at the level of individual atoms. We're getting to a point where we can... But enough about what we know. What I really want to talk about is what we don't know. Because I believe that the most important product is being informed, intelligent ignorance. The knowledge brings you to realize that there are new questions that you didn't know enough to ask before. Most of the questions that were asked about basic physics, when I was a student, have been answered. The questions show the history of the universe. The part we know least about is the beginning. We actually have a picture of what the universe looked like 13.5 billion years ago, 200,000 years after the beginning, right here. Before that time, the universe was a hot, dense gas, and the light in that universe fog everywhere. And you know, when it's very foggy, you have fog in Cambodia sometimes? When it's very foggy, a cloud, you're in the middle of a cloud, you can't see anything. Well, about 200,000 years after the Big Bang, or 400,000 years actually, suddenly atoms form. Electrons and nuclei form atoms, the light would flow, and we can take pictures like this one of the light that flowed from faraway parts of the universe for 13.5 billion years without hitting anything. And this is a picture of the density of matter and radiation in the universe 13.5 billion years ago. The colors represent where there's a little bit more matter and a little bit less. It's actually been the differences in density, clumpiness, have been exaggerated here by 10,000. The universe was a very homogeneous gas, very hot at that time. And before then, we think we understand something about the gas until we get back close to the beginning, which is often called the Big Bang. It was not a scientific question. It was maybe a religious question. It was a question that was not addressable by observation, experiment, or theory. Today, it is very far back, and we try to go back farther and farther. Looking at that picture, that baby picture of the universe, we see phenomena which we can say occurred 1/billionth of a billionth of a billionth of a second after the Big Bang. So we are probing back near to the Big Bang. But can we actually say how the universe began? Another question we're asking is, what made light from that? The universe has become a very lonely place. We don't know. This cosmological constant, as I said, where does it come from? Well, we believe it comes from the vacuum. And I want to tell you something very profound that we have learned in the 20th century about the vacuum. Now, you might think the vacuum, which led us to the theory of the nuclear force called quantum chromodynamics. And here's another picture from calculations in quantum chromodynamics of what happens when you pull the quarks apart. And the field that transmits the force between the quarks are restricted, squeezed by the vacuum to form a tube. But people showed there was no such ether, because an ether would look different to somebody at rest with respect to the ether, or somebody walking through the ether. And both experiments yielded the same result. The properties of nature don't depend on your velocity. That's Einstein's theory of relativity. Side with Albert Einstein, who believed that in the end we will understand this number as well as everything else we've understood. We haven't been able to test it. And no idea is correct or even to be believed until it is truly tested and its predictions are confirmed. Perhaps the most profound of the questions we ask has to do with space and time itself. Descriptions of many, many atoms how to approach that idea and to one is genomics. Data now, we have sequence to acquire data, quantitative data at the genomic level about evolution. If you take the genome of that, I think that will be possible, and I imagine theoretical generalized phenomena. So what kind of change is this? What consciousness is? You try to find
Yes, thank you, sir. My name is Uwe. I just come from the NPIC school, that stands for National Polytechnic Institute of Cambodia. Yes, I have a wonder question. One thing. I study about physics too and electronics. Yes, my major is electronics. I wonder that why does electromagnetic come out across the metal? This is the question. The first question has two. Do you believe that Einstein theory? Yeah, Einstein theory that if someone when that drives one machine that has the speed 30,000 kilometers per second can be younger than before? Yes, that's all. Thank you.
I didn't get the first question, which some of you might know is a phenomenon. Clocks slow down. So if our twin goes on a trip close to the speed of light for many years and then returns, is you take an atom, a particle that is radioactive, is going to decay, and it has a half-life of, say, 1 minute. And then you put it in an accelerator so it's going with the speed of light. Almost. Very fast. And its clock runs slower. Experiments are done all the time in particle accelerators that accelerate particles that age and decay, and they stay younger and younger.
This is Ketan. I am a lecturer in the Department of Physics here. So I quite confused with dark matters and dark energy. So what difference between dark matters and dark energy? The black hole can be considered as dark matters or dark energy.
Black holes, see, there is a there because you see the orbits of other stars around this object, just heavy matter of a new kind. What the vacuum I talked about, no. It is just property of the vacuum. Slowly, so it has friction, dissipation, ordinary matter.
So I still have one more question related to the strong force. So let charge in electricity and materials, we say the interaction force between two charges as inversely proportional to the distance. But what difference between electromagnetic force and strong force? That if clocks are far away.
Very good question. Why is it different? If it wasn't for the quantum mechanical structure of the vacuum, it would be inverse square law and nothing else.
Sorry, teacher,
Could you just switch it on the microphone? Picking up.
Bring him up.
About English clearly, but I need a supporter to translate my question because I have now in my mind so much, but I want to ask my question in my mother tongue. Yes. ជំរាបសួរលោកសាស្ត្រាចារ្យជំរាបសួរចង់សួរថានៅពេលដែលមនុស្សដែលលោទឹកសម្រាប់ខ្លួន ហើយអ្វីពេលលោកទៅសម្លាប់ខ្លួនទៅគេស្លាប់ហើយសាកសពរបស់គេតែលើវិញ So this is a simple question that I ask you because I come from the mind picture. Thank you.
I get the float on the water.
Say it again.
What did I say?
Why?
And after that is up to the surface of the water.
But since I am a theorist, I'll build a theory full of gas, and our volume increases, our specific density decreases. That's just a theory.
Thank you for the answering. Is there any possibility that there is another planet that supports life in the galaxy? And what happens when two galaxies collide with each other?
So that's a very good question. It's hard to see them. So how did they discover them? They discovered them because planets pull a bit on the moon, the sun, on the stars they revolve around. And if you look carefully at the star, you see that it jiggles a bit because of the planets going around them. And you can determine what it is that causes the star to jiggle. They discovered first heavy planets very close to their stars, but by now there are around 400 to 500 new planets that have been discovered. Lighter and lighter, more like Earth. And astronomers are discovering new planets every day. Science together, we're starting a program next week, in 1 week, on exoplanets, on planets outside our solar system. Now, what happens when two galaxies collide? Well, you know, we are going to collide with another galaxy in about 5 billion years and separate. It's like a pendulum. Now, during that collision, most stars won't notice very much. Space is very empty, even in the middle of a galaxy. As you can tell by going out in the night and looking at the other stars, they are pretty far away. So what happens is not that individual stars collide, like two railroad trains on the same track that we burned to smithereens.
Thank you, Professor. So, Department of Science Research, Ministry of Education and Sport. First of all, I would like to thank our organizer to organize this very important meeting, and thank you for Professor Cross that agreed to come to give a wonderful lecture. My question is, as Cambodia is a developing country, and from Ministry of Education, Youth and Sport trying to promote science and authentic education, we would like to know by your experience, because we know that you are sacrificed on your life in science. What you could share your experience, your idea with our students, our lecturers and researchers, what we could promote science and authentic education in Cambodia and find easy way to implementation and high impact and find the low cost. Thank you very much.
The part about science, because you have the resources sitting behind you, young people who have given the opportunity, exposed to new ideas, to the excitement of science, and opportunities will take them. So the resources are all ultimately in the heads of young people. You have to just provide them with opportunities. It's easier than science in many ways than in something like heavy industry. But you have to motivate young people and give them the opportunities. I can think of many ways to do this. I'm not sure. You have to be ambitious. You have to be ambitious yourself.
Thank you, Professor. So, Mr. Chairman, I'm sorry to inform you that actually before we plan to finish our event at 5 o'clock, but because the Professor is having a meeting with the Minister of Education, Youth and Sport at 4:30, so as a result, we have to finish our event by now. However, before we end, in order to express our sincere thanks to our Professor, so now I would like to invite Her Excellency Prince Again in order to present the souvenir and also the letters of appreciation or certificate of appreciation to the Professor. Please. Thank you so much, Your Excellency and Professor. Next, I would like to invite His Excellency Chiu to present the appreciation, the certificate of appreciation to Mr. Uwe Morawetz. Thank you so much. So once again, Her Excellency, His Excellency, Professor, our distinguished guests, students, ladies and gentlemen, on behalf of the organizers of this event, I would like to say thank you so much for your attention and for your time to be in this event. And last but not least, let me express my sincere thanks once again and the closing of the event with my formal regard.
Yesterday about 5:30 yesterday. Quả lớn nhà không cuộc sống thuộc lấy cái này trong ổng lên kia từ nhà nước nhà tự nhận lại.